this is going to be a brief video tutorial on how to run an IRT analysis on IRTPRO. So if you go to your textbook on page 120, it walks you through how to do a very simple unidimensional IRT test over here. And I'm going to show you how to download the program, pick the right data set, run the analysis, and show you where the results are at so you can interpret it according to guidelines in your textbook. So first of all, it's pretty easy. If you want to download the program, just search for IRTPRO. And I want you to pick the free student edition, because the nice thing about this edition is that it has a couple of example data sets that you can use for this assignment and for your own practice. And we will be using one for the example in this video tutorial and another one for your assignment. So let's click over here, and unfortunately, just like what your textbook says, there is no Mac version, and so you would want to use this on the Windows computer. So if you don't have a Windows on your Mac, just go try to find one somewhere on campus. There are great resources that you can plug into. If not, you can get in touch with me. So let's download student setup.exe. You're going to save it. So downloading. Yeah, it's going to take about 40 something seconds. So let's just give it a minute. Actually, you know what? I already have this file in my computer. So let's just fast forward. I'm going to open a file that I already downloaded when I was test running this thing. So once you download the file, open the file and click Run. It's going to prepare to install. Click Next. Accept. Next. Complete. Notice this is where they're talking about they have example files installed in which folder. So it's in C drive IRTPRO for student examples. Alright. And you may or may not have this depending on if you have several users on your computer. Alright, let's launch the IRTPRO student for Windows. Alright, so this is the general user interface right here. And what we want to do is we want to first of all import some data. So for this example, I'm going to use, actually, let's scratch that. Let's go to File, and Open. It should bring you directly to the folder that has all the examples. So make sure you go to IRTPRO for student examples, unidimensional 2PL. For this example, we're going to use the self-monitoring one. And one thing that you want to do is you want to click in the bottom right tab over here and click on SSIG data file. So this is where you're going to open up the data on the user interface, and then you can point and click. The command file, which is default over here, is basically the computer code or the syntax for you to run the analysis. But since I'm just showing you the point and click version, let's open the data file. So it's a different format. You might notice that the data file is .ssig as opposed to .irtpro. So make sure this is .ssig. And let's click in self mon for items .ssig. All right. So let's see if I actually have. Just give me a second. I have some description of this data somewhere in here. Can't seem to find it. So I'm just gonna tell you what I remember from memory. this data is actually a subset of a larger data set coming from a self-report questionnaire on self-monitoring. And so there are 4 questions in here. So like question number 8, for example, the columns are items, the rows are people. A person would basically read a statement, something along the lines of, I'm usually pretty aware of my emotions, or I know how other people feel in any particular social situation. And the respondent, the person who is reading the questionnaire, is going to indicate whether that is true or false. And so what we're going to do with this program right here is that we are going to analyze 2 characteristics of the item when used with these people. First of all, if you go to page 117, we're going to figure out the discrimination level defined by A, and you'll see in the output it's also labeled as A. So when the curve is steeper, there is a larger difference in the probability of a correct response for those whose theta values differ. Theta values refer to their trait ability. So what you want for A in terms of the discrimination level is a large value. The larger the value, the larger the probability that you'll be able to distinguish between 2 different people who have different ability levels. The smaller the value, the worse the item is able to discriminate amongst people with different ability levels. So in this particular example, the ability level is self-monitoring. The other value that we're going to try to output from this program is the difficulty level. So the higher the value of the difficulty level, sometimes labeled as B, just like how it's done in this program, the higher the value, the more difficult the item is. When the difficulty level is less than 0, the likelihood of a correct response is greater than 0.5, which is greater than half. These are really easy items. You can pretty much guess. And you have a larger than a coin flip, basically. Probability larger than the coin flip in terms of getting it correct. When B is greater than 0, the likelihood of a correct response is less than 0.5. And so it's a lot harder for you to guess these ones when B is greater than 0. So again, your columns are the items themselves, the rows are the specific people, and I think we have 393 individuals in here. So what you do is you click on analysis, click on unidimensional IRT, and you want to title this, let's just say example unidimensional IRT. And what I would want you to do for your assignment, because the title and the comments are going to come out in the output. So I want you to write your name, and that's all I would need, just to make sure that, just to help me figure out whose file is whose. We can skip group because we're not going to compare any particular groups over here. Sometimes we use IRT to compare how items function across, say, different genders, different races, different classrooms, those kinds of things. But that's beyond the scope of this class. For items, we're going to select all of them. Click Add. We usually shouldn't have to mess around with models. 2PL is basically a statistical model where an individual's response to a binary item, so like true or false, for example, is determined by 3 things: the person's trait level or ability level, the item difficulty, and the item discrimination. What we're interested right now for this assignment is the item difficulty and the item discrimination. So 2PL is the default. The data codes are 0 and 1 as the true or false. Item scores are the same. So we should be good. So if you click Run, it's going to produce you an output. Now, if you compare what we have over here in this first table and what you have on page 120 to 122, it should give you an idea about how to interpret. we're looking at, again, item discrimination level A, which is these numbers over there. Remember, the larger the value, the better. And item B, which is item difficulty level. So the larger the item, the more difficult that item is. And for your assignment, I want you to basically interpret this table based on the guidelines provided on pages 120 to 122. So I want you to do this for me. Highlight this table and everything else up to the very top. Copy it. And just open up a Word document, and I want you to, there you go, paste it. And save this as whatever you would want to save it. So I'm just going to save this as example. And when you submit your second quarterly assignment, the Word document that goes together with that, I want you to also submit this Word document as well, so I can cross-check your numbers over here to see if it's done correctly. You can see that the output also tells you when you run the analysis and what time. The title was over here. The description, your name it came up over here. So I want you to basically submit this together with the Word document for question number 2 in your second quarterly assignment. So that is it. Let me know if you have questions. I hope you have fun with this, and take care.